Hello guys, welcome to this lecture. We're continuing our discussion on probabilities. Today we're going to talk about discrete probability distributions. Well, we already talked about discrete before, and discrete variables have to do with variables that can be counted or listed. Decimals are not allowed. For instance, if I am talking about the number of heads that I get when I toss a coin, the possible answers could be 0, 1, 2, 3, 4. You cannot get 1.5 heads. The number of houses I get when I count households, the number of houses in a particular district. So these are random variables. We define random variables as numerical outcome of a probability experiment. Okay, so we're going to be looking at such distributions today. These are objectives. We're going to distinguish between discrete and continuous random variable. We're going to decide if a given distribution is a probability distribution. We'll find the probabilities, both single and cumulative, and of course we're going to compute the mean, standard deviation, and variance of a discrete random variable. Okay, so let's first start with the rules, some of the rules. Here we've talked about the first one. We said that probabilities, each individual probabilities must be between 0 and 1, 0 and 1 included. So if any probability is does not satisfy this condition, then it means that it's not a probability distribution. Okay, the second condition is that the sum, when you add all the individual probabilities in the distribution, the sum should be equal to 1. No more, no less. Okay, so let's look at this simple example. We're going to look at this table. We have random variable x and the probability of obtaining a value for the random variable. So the probability for that x is 1 is equal to 0.25. The probability that x is 2 is 0.45, and so on. So we look at the table below. We're going to answer the questions. The first thing is asking if this is a probability distribution. And to answer that question, we're going to look at the two conditions. Now look at the individual probabilities in this distribution. You can see that each of them is less than 1 and more than 0. So that part of the condition is met. Then the second condition is that if you add the probabilities, it should be equal to 1. Does that happen? Yes, it is. So the two conditions are satisfied. So we can say that yes, this is a probability distribution. And why? Because both conditions are met. Okay. Now we'll go further. Probability of getting A2 is right here, 0.45. 0.45. The probability of x being less than or equal to 2, which means you start from 2 and go down, 2 and 1. So add the probabilities of 1 and 2, that will give us 0.7. Then the probability that x is greater than 3 should be these two probabilities, 4 and 5, greater than 3, which means 3 is not included. So that's 0.25. And then probability at least 4 means that 4 is the smallest. Or 4 is the smallest, correct? At least 4. So we add the 2 again, 4 and 5, at least 4. So it's 0.25. Okay, at most 4 means that 4 is the highest, so we add the probability for 4 and all other probabilities below 4. That should be 0.85. Okay, so the next question is for us to find a standard deviation and variance of this distribution. Okay, so to do that, we are going to go to start, turn it on, and go to start and then edit. Now you can see that the values are already entered. The x values are in L1 and the probabilities are in L2. So we are going to go to stats and go to calc, and we're going to select one variable statistics. What happens here is that x is going to be our values, the variable, while p of x, which is the probability, will serve as our frequency. Okay, so we're going to do that. So you can see lists is x is L1, and then frequency list should be L2. So we're going to select 2, second 2, that's L2, and then we are going to calculate. Okay, so if you see here, we're going to, let's add mean here. Let's add mean column here, or below, above. Let's do it above. So I'm going to add a row above and call it mean. So the mean in this case is 2.45. Okay, and then the standard deviation, we're going to choose, of course you can see here that there's no sample standard deviation. We only have the population standard deviation. So we have the standard deviation as 1.360 in 3 decimal places. And then the variance, remember we said for you to get the variance you have to square the standard deviation. So the variance is going to be 1.360 squared. That gives us 1.850. 1.850. Okay, so that is the variance. Now we take a look at the second table. The question is this a probability distribution? Well, I can see that one of the probabilities is negative. I will know that probability cannot be negative, so it violates the very first conditions we set, which tells us that the probability cannot be less than 0. It has to be between 0 and 1, from 0 to 1. So we say that this is not a probability distribution because one of the probabilities is negative. Okay, so in doing this, since it's negative, there's no point going further to answer the rest of the questions. Okay, so that is how we can find the probabilities and mean, standard deviation, and variance. Remember, you can do this by hand. You can find the mean, standard deviation, and variance by hand, but I just chose to show you how to do this using the TI-84 plus, which is easier to do. Okay, so I'll see you next time. Thank you. Bye bye.